I built this visual network mapper using Antigravity in less than 40 minutes. This would take a development team typically 1 or 2 weeks. Hello, friends. So today we're going to do something really, I think, pretty cool. I've used Antigravity quite a bit. I've written several applications in it. And what I want to show you today is how we can create a visual network mapper pretty much just using prompts. So we're going to start out, we're going to make this a full stack app. So we're going to have a API written in Python using FastAPI, and we're going to have a front end using Next.js. So for my prompt over here, I'm just going to say create a Python FastAPI backend using SQLite. So of course we could always extend this later if we want to connect it to a real database. We could do that, but we'll just start with SQLite just for the proof of concept. I need 2 Pydantic models, one for device, which is going to include an ID, host name, IP address, role, and status. Okay, so it'll be like IP, host name, or sorry, ID, host name, IP address, role, switch, router, firewall, and then status will be something like, up or down or something like that. So that's the one model, device, and then connection, source ID, target ID. So of course we're going to have like a switch connected to a router, and then bandwidth. So we'll include the bandwidth between the two. All right. One other thing I'm going to add to generate a seeding script to populate the DB with, let's go with 20 realistic network devices. So this will include things like firewalls, core switches, access points, and random connections between them. Okay, so we'll see if it includes anything else like edge switches, or if we'll see. It may add something else. I don't know. It might add client machines. I'm not really sure. The goal is to be able to test API functionality immediately. Okay. All right. So notice here, I've got over here on the right, I'm using the Gemini 3 Pro model, high reasoning. I do have options here to use Claude or GPT OSS. I have not really had great fortune with GPT OSS, so I generally stick with Gemini or Claude. I'm going to stick with the planning mode here, the conversation mode, so this way it's going to generate an implementation plan and tell me, it's going to tell me what it plans to do before it actually does it, and we can read through the implementation plan. So it goes through and walks through the reasoning. It's creating a task. You can see it pops up the task here, so it's laying out the plan, initialize the project structure, and there's our implementation plan. So let's go read through, let's look at the task list real quick. Create requirements.txt. This is going to be the requirements for Python. So I can tell right off the bat here, it's going to just probably use pip virtual environment here. Not going to use UV. I guess if I prefer UV, but I always have to remind it that I want to use UV. I'm not going to do that here. I'm just going to go ahead and let it do it the old way. So to create the requirements, set up the database logic. So that's probably going to be the seeding Python file there. Define SQL Alchemy models. All right, so it's going to use SQL Alchemy for the ORM, which again, we're going to be using SQLite on the back end, but this is good because we could always plug this into Postgres or some other real SQL database. Pydantic, and then define the API routes. Okay, okay. So the seeding script is seed.py database.py. All right, so we're gonna have to kind of figure out what it came up with here. It doesn't always come up with do things the way that I would do it. So it's going into detail here. Here's the project structures, dependencies. It's going to use Uvicorn, SQLite connection, and session local setup. Okay, so this is going to be handling the database connection. Models.py sets up the models. We've got the schemas for our Pydantic and main and seed. Okay, this looks good. So here's the database schema. So we gave it explicitly. We told it what we wanted. Looks like it's stuck with it, and it recognized here that source ID and target ID, these are going to reference foreign keys in the device table. And then verification plan, run seed.py to ensure we populate the database, start the API with Uvicorn, which is just basically a little web server, and then we'll use curl to do a get against the devices and list the connections. All right, so I'm not, all right, so it hasn't created anything yet. So over here on the right, I've created the implementation plan. We can click proceed. And I want you to see just how fast this thing can go. So it's commencing the application build. It's been working for about a minute here. And you can see up here in the tab, I can see it's creating the files. There's my models.py. So I can go and actually check the code as it's creating it. There's the main.py. So here's my endpoints. We've got a devices endpoint. We've got a post for creating devices. There's the post method, get devices, device ID. So we've kind of got our CRUD functionality here, right? We've got creating a device. We can get one device, get all the devices. We can create connections. We can get all the connections. All right. So this is starting to look just like a normal FastAPI app. And now here, notice on the right, it says requesting your permission in terminal. And what it wants to do is it wants to do a pip install against the requirements.txt and then actually run the seeding program. So let's go, and I could just trust this thing and just let it do whatever, but I'm going to go and actually look at requirements here. Okay, so those are the requirements, and it wants to run seed.py. So here's our create devices function. So it's going to create a fake IP address, fake host name, and basically just select random connections. All right, so this all looks good. I'm going to go ahead and click accept here. And what it'll do is it'll sort of run it in a little terminal window off to the side here, but you can click this little icon and it'll bring up your regular terminal. Move this over a little bit here. All right, so here it's saying correct Python to Python 3. All right, so this is one of those little things where you sometimes have to go in and correct it. You have to remind it, all right, Python 3 and not Python. So in this case, my terminal is letting me autocorrect to Z shell. So I'm just going to say yes, let's correct. Getting a warning, you may have installed Python packages into your global environment. Would you like to create a virtual environment? All right, so very interesting here. It did not actually create a virtual environment for us. Sometimes it does, sometimes it doesn't. All right, defaulting to user installation. All right, so let's go down here. I'm actually okay with it doing the global install because I probably have a lot of these packages already installed, so it'll make it go a little quicker for me. So again, a lesson about this is you want to be very explicit. If I wanted a virtual environment, I should have said I want a virtual environment. If I wanted to use UV, I should have said use UV. And it would have done it. It would have worked just fine. I've done it before. But if you don't tell it, it's going to kind of default to more likely the older way of doing things, but it's hit or miss. Sometimes, it might actually do a virtual environment even if you don't ask it to. All right, so here we go. Let me scroll up a little bit. It ran the command starting API server and testing endpoints. Okay, so I'm not, let's see here, Python 3 seed.py. Let me just double check what it actually did. Pip install requirements. Okay, oh, it did run it. All right, so creating 20 devices, creating connections, seeding complete. So this is kind of funny here. I just want to go through the chain of reasoning here. It said checked command status, and it goes, let's see, sorry. This thing will move a lot on you too, so you have to go back up and look at it. I'm investigating a potential hang. The output is concerning, right? It's very dramatic sometimes. So the output's so concerning. Checking if the network.db file exists. Oh, let's see. I wonder if it does. Yeah, it's over there. All right, let's see what it came up with. I'm checking the existence of the result, which is this database file. If this database exists, I know I can start the server. So it's kind of interesting how it doesn't seem to know that the network.db file actually exists. So what it wants to do is it wants to do a directory listing. I'll just go ahead and click accept. There it sees the directory listing. And another thing too is, it can see the terminal. The Antigravity agent can see what's going on in your terminal. So it sees the network DB there. Now it wants to run Uvicorn. We're going to run it on port 8000. So yes, I do want to run it. All right, so there's my Uvicorn. Uvicorn's running on my loopback address, port 8000. And now it's talking to itself, saying some things about using JQ. Running a verification script to test API endpoints. Okay, so this Uvicorn's running in this one tab. It's probably going to open up another tab. Okay, no, it actually broke out of it. This will be interesting. So here again, it's trying to use Python. We'll let it correct to Python 3. Yes. Okay. Verify API. So I'm curious. I want to look at this. Base URL, import requests, Checking devices, wait for API. Okay, so I see what it did. It left the Uvicorn running in the background. You can see it put the ampersand there, so it backgrounded that process, and that's why it was able to go ahead and run in that same terminal. All right, so it did the get docs, get devices, get connections. Now what does it want to do? It wants to see if the server's running. Now that's kind of interesting. I want to just slow it down a little bit to see if it knows what it was doing. So it ran the test. Okay. Checking if server is running and debugging verification script. So for some reason it seems to think the verification script didn't work. I'm not really sure what that's about. So now it wants to see if Uvicorn is running. All right. So again, it sometimes does things that don't really make any sense. It seems to think that its test failed. I'm not really sure why it thinks that. So now it wants to use curl to connect to the docs endpoint. All right, so here's our Swagger docs. Pretty cool, right? It created the Swagger docs for us. And now what does it want to do? Oh, request review. Let's go down here. Scrolling down, there's like nested windows here. All right, devices. It wants to use curl to use devices or view the devices. Okay, so a bunch of JSON all mushed together. And now it wants to kill a Uvicorn. Okay, I'm going to let it do it. I'm just going to let it run through. And I mean, I'm satisfied at this point that the API is working, but maybe it's wanting to do something else. So another thing I really like about Antigravity is that it creates these walkthrough files. It tells you what it did, what it created, why it created them, what they are, what they're for. It gives you the different CRUD endpoints, right? So this is very cool, all right? Go to the walkthrough, all right? So it pretty much says at this point, it says, I'm done. I've done what I needed to do. So we could be satisfied with this. I do want to go through just real quick. One thing I like to do is tell it to create a little README. So create a readme.md file with instructions for starting the API. So this should only take a few seconds. Pretty basic thing. So it looks like it had a little debate with itself about whether it should actually do what I asked it to do. All right, so anyway. So here it is. Here's the README. It gives us the install, pip install, seed the database. We already seeded it, so we should be good. All right, so if we want to run it, again, Uvicorn main app -- reload, which will reload it upon file changes. All right, 127.0.0.1 So what I'm going to do now is I'm going to open my browser up. Let me open up Brave here. So 127.0.0.1 All right, I'm going to go to the Swagger docs here. Docs. All right, very cool. So there's my create devices, read devices. Let's go ahead and try it out here. Looks like we've got some pagination ability here. All right, very cool. Oh man, oh, it's giving us these weird host names. Oh my goodness, I don't know where these came from. Crazy looking fake IP addresses that might be real. I don't know. We've got role server status active, active and offline. So it seems to have taken, oh, maintenance, all right. So sort of come up with some weird status designations there. And let's look at the connections. Get the connections. I want to see what this looks like too. Execute. All right, I think that's pretty cool. So there's one, just again, it's all JSON, source ID, target ID, and then it actually apparently is doing some kind of a join there to get the source details. So this is really cool. I mean, this would have taken us a while to do this by hand. So I mean, right now, this is a huge time saver. I love this. So that was the API. By itself, somewhat useful, but we really want to tie this into a front end. We want to tie this into a Next.js app, which is going to use React, and it's going to give us a map. It's going to let us actually see and visualize all these connections. That's what we're going to do next. So we've got our API already up and running. What I'm going to do now is provide another prompt, build a Next.js front end using React Flow. So this is going to be, React Flow is going to be for actually moving the nodes around. We can see the nodes, move them around. Kind of gives us a little bit of a more realistic looking graph, you know, where they sort of bounce off each other, push against each other. Fetch the JSON data from the Python API. So we're going to hope that it knows what we're talking about here. Map device objects to nodes and connection objects to edges. All right. So again, a node is going to be like, you think of a graph. You've got a node, and two nodes can be connected via edges. All right. So we're just basically describing how it's going to map the devices and connections to the components of the graph. If bandwidth is, all right, I want to go, let me see, if bandwidth is, I need to go back and look at what it came up with for the bandwidth. I didn't really pay too much attention to that. Did it even show bandwidth? All right, go down to the connections again. 1 gig, we've got 1 gig and 10 gig. 1 gig and 10 gig. Okay, so let's go back here. So if bandwidth is 1 gigabit per second, make the edge line, I said it was 1 gig and 10 gigs. So let's make the edge line thin and gray. And if bandwidth is 10 gigs per second, make it thick and green. So we can kind of visually see, what's the slow connection, I mean, to say 1 gigabit is slow is kind of funny nowadays, but 10 gigabits has been around for a while. So we're going to use a particular library, DAG RE library, to auto layout the graph so nodes don't overlap. Okay. So we're going to use the DAG RE library. DAG is directed acyclic graph, RE for React. So we're going to use this library, and hopefully this will all look okay. I don't expect this to look wonderful, but I hope it's at least functional. So let's go ahead and give it the prompt. And by the way, if you want to see all the code for this, I'm going to push this up to my GitHub, github.com/BenPiper, and you all can check it out. All right, it says I've updated the implementation plan to include the Next.js frontend with React Flow. I'll enable cores on the back end, ready to proceed. All right, I want to look at the implementation plan, because again, this stuff it's really good, but every once in a while it will do some weird things. So what is it doing? Implementation plan, network, backend. All right, I'm only seeing stuff for, okay, backend update. It's going to enable cores in the backend. All right, so this cores is basically, it's going to make this change to the backend to allow the front end to communicate with the backend. Okay, calculating node positions. All right, there's the front end. Sorry, I just missed it because my eyes just went right over it. Next, Flow, Dagger, and Axios. Okay, so it's going to be using Axios to connect to the API. No problem with that. Typically, again, I would probably use Fetch, but Axios is very common, very popular. That's probably why Gemini picked this. All right, so enough talking. Let's go ahead and proceed. All right, so it wants us to, all right, npx create next app. Okay, so right off the bat here, I get a little concerned with this because I want to know where it is. All right, so it's going to use create React or create next app. What is it going to call it? Front end. All right, so I expect it to create another folder here called front end. Now this is sort of making me second guess what I did initially with the API. I wish now that I had created a separate backend folder. I wasn't sure if Antigravity was going to do that for me, if it would be smart enough to create a separate backend folder, but it didn't. It just did it in the folder that I was already in. So lesson learned, maybe next time if you're going to do a full stack app, create a separate folder for the backend. Anyway, it's going to run the Node package runner, create a next app. We're going to use TypeScript, Tailwind, all the good stuff. Let me go ahead and bring this tab open here so we can see what it's doing. Now, this is interesting because the Create Next app is asking us for a prompt here. Antigravity wants to say no. Would you like to use React Compiler? All right, so I'm going to go ahead and accept its input there. Installing Tailwind, TypeScript, ESLint, and then of course React. Installing the front end components always takes a lot longer than the back end. One other thing too that I should have done is I should have initialized a Git repository, and I should have gone ahead and committed my changes once I got the back end working. So I'm going to make sure once this is done, I go ahead and do all that. All right, cool. So now that it's initialized the folder structure there, you can see the front end folder. We got our package.json. I'm not going to just start opening a bunch of files. I'm going to sort of trust it a little bit for right now. It wants to do the npm install. It's going to install React. And just the fact that it's doing TypeScript and all the types for us, that is a huge time saver. Using TypeScript, you're pretty much debugging in code versus debugging in production. I'm resisting the urge to go and start opening all these component files and looking at the components. Like I said, I want to just trust this thing and see what it comes up with. Well, it opened it up for me, so there it is sitting in the tab. All right, I'm going to go look at it. So here we've got our network map component. All right, so now it wants to npm run dev. I will, just out of curiosity, I'm going to go ahead and open up my package.json. Npm run dev is just going to run Next.js. All right, so I'm okay with that. Let's go ahead and run it. And to be honest, I'm kind of hoping for some kind of bug because I want to show you how Antigravity goes and fixes its own bugs. But so far, this is actually pretty good. Okay, so now it wants to hit localhost 3000. So our front end is running on 3000. Our back end is running on, I think it was 8000. So let's go ahead and let it run curl. Okay, so there's our headers. It's updating page.tsx. All right, let's go look at the walkthrough. Oh, it learned. It takes me to the walkthrough and it says how to run. All right. So there's the back end, how to run the back end, very good. How to run the front end, it even tells me, all right, go into the front end directory and then npm run dev. All right, so npm run dev, that's already, front end's already running, access at localhost 3000. All right, now the network engineer in me wants to go look at the code on the front end and see exactly where it has the connection to the back end, which is it going to be localhost 8000? Is it going to be 127.0.0.1? I don't know. But let's go ahead and go to our browser here. So there's my Swagger docs. I'm going to do 127.0.0.1:3000. Okay. I mean, it's it's school project, but visual network mapper. There's our nodes. So we've got the 10 gig node here. I'm going to zoom in. Sorry, this is really, really tiny. I'm going to have to zoom in way much. All right, that's a little better there. So I can move this around. So we've got our connection between these two. I can move them around. This looks a little weird. What's going on with this? I guess it's these two? Oh, I'm confused now. What is connected to what here? All right, so it must be these LT26 and is it LT or IT? Okay. We may need to fix that. So whatever this is, LT or IT26 connected to LT05, 10 gig connection, so it's thick green. That's what we wanted. 100 megabit connection is okay. This is kind of weird. So I'm seeing the gray. I don't know what's going on here because this says 100 megabit, and I actually see. Oh, I see what it did. It actually created both because I'm seeing the little gray. I don't know if you can see that. There's the thin gray line. So apparently it did some weird stuff with the connections there. All right. So again, this isn't 100%, right? We would not just put this in production. We would have some big problems if we just trusted this. You can see and this is really more to do with the seeding part where we may need to revisit the database design. Of course, it's certainly possible that we could have, both a 1 gigabit and 100 megabit connection between these two, but in that case, we would still probably want it to look a little different. We wouldn't want this overlap here. All right. So this is cool. I can move things around. It actually has the ability to zoom directly in, so I don't have to. Let me unzoom my browser so we can see what this looks like. See if the functionality of this looks right. Okay, where did it go? No, that actually was my browser. All right, my bad. So let's zoom in a little more. Go back to it. And I'm going to want to change the prompt a little bit here. So let's go back to Antigravity and let's say refactor to look like a real knock dashboard, not a school project. All right, I'm going to be a little snarky. Sometimes I get a little snarky with these LLMs. All right, so if I just leave it at this, there's no telling what kind of garbage we might get from this. So we need to be specific. Let's change the background to, I'm going to use my brand colors here. And I want to run a little test against this too, because typically when we specify colors, we'll give it, hex color, RGB. But in this case, I'm going to do the CMYK, and see if it can figure out and get it right. I already know what the hex is supposed to be, but I want to give it this just to see if it performs the conversion properly. Nodes, we'll do glassmorphism, the little glowing glass look. Cards with how about some like neon glowing borders based on the status. And so we'll do red is critical. We had like the critical status, and green is active. And now I'm wondering, was critical, what was the status? There's active. All right, now I got to go back to my Swagger here. Let's look at the status. All righty. There's active maintenance. What was the other one? Offline. All right, so we'll go with offline then. So red is offline. All right. Now, I want y'all to really pay attention to something here. What did I fail? Why is it that I'm now having to go back and say, is it offline? Is it critical? What is it? It's because I failed to design the database and the model to start with. I kind of left it up to the model, to the Gemini model here to figure that out. And now I'm having to go back and figure out what it did. All right. So lesson here is, if you're going to do something like this, get the design down really well, and tell it what you want the design to be. Because if you don't, it's not going to say, hey, it's not going to ask you and say, hey, what do you want here? You're missing something. It's going to say it's going to come up with its own thing, which is both good and bad, right? It's good because if we're lazy, it'll just do it for us, but we have to go back and now figure out what it came up with. All right. Let me change the font. Font needs to be monospace for all IP addresses and host names, right? Because I didn't like I think it was Arial or something. I couldn't tell if it was an L or an I or what. Okay. Should we push this thing to the limit? Should we add any kind of animation? You know what? Yeah, let's go ahead and do it. Let's do a pulsating CSS animation to any node. So we'll make the node sort of pulsate like a heartbeat with offline status. All right. So this is the ultimate user story nightmare, right? As a user, I want pulsating nodes, glass cards, neon glowing borders, like a kid in a candy store. All right, let's go look at the implementation plan here. UI refactor, Knox style, dark, deeply saturated background. All right, so here I gave it the CMYK, it came up with the hex 134080, and that is exactly right? That is my dark blue brand color. Custom node, device node. Okay, so it's going to create a separate React component for the device node, glassmorphism, topography. We've got status indicators, green neon glow if active, red neon glow plus pulsating animation if offline. Oh, look at this. See, now there's maintenance. That was another status, and I intentionally ignored that because I wanted to see what it would come up with. So it came up with amber glow. I'm okay with that. That's not bad. Keyframes for pulsating effect. Okay, so let's go ahead and proceed. And by the way, we're less than 40 minutes into this thing, and we've already done probably hours worth of manual work. Just going to go look at the device node real quick. See, it even commented its code. All right, so now it's ready to go ahead and... Okay, well, that was weird. It acted like it wanted to run curl, and then it changed its mind. All right, let's go back to the walkthrough real quick. So nothing... We shouldn't have to do anything differently. I should just be able to go back to the page, and this being a React app, should auto refresh for me. Let me go ahead and zoom in a little bit here. Okay, this is cool. Look at this. So you can see the pulsating red. We've got, man, this network is in bad shape. We got things down. We got things in maintenance mode. Zoom in a little more so we can see it. Hoover.org. I mean, that's probably a real domain name, but Well, I'm glad I changed the font because now I can tell it actually is an L. It's LT. So I can move these things around. Oh, there it goes. All right. I built this visual network mapper using Antigravity in less than 40 minutes. This would take a development team typically 1 or 2 weeks. This is a complete full stack app. So again, if I were going to do this again, I would be a little more explicit about the data modeling. I would be a little more explicit about exactly what I want the front end to look like. But the API, it pretty much nailed the API, all right? So it did a lot of the boring work for us, and now we have pretty much the starting point of what can be a professional visual network mapper, and again, did this in less than 40 minutes.